Already. Hey everyone. So as Matt kindly said, I'm John. The main reason I'm standing in front of you all here today is I currently have the pleasure of being one of the maintainers of a little Ruby project called RSpec. So today's talk, Tales of Interest, stems from my experience in working on RSpec. But it might need a little bit more explaining than that. The blurb was kind of intriguing. We talked about the sort of problems and challenges faced in working with open source. So you're probably asking yourself, what have I let myself in for here? Is this going to be a massively technical talk? Is this talk just going to be about RSpec? Or have I forgotten to turn the
Pretend I'm not here.
I've forgotten to turn the microphone on. Is he going to lecture us on RSpec all day? Because, man, I hate that sort of shit. Well, I am going to be talking about RSpec, because that's kind of why I'm here. But that's not the real point of this talk. The point of this talk is actually about open source, about the experiences involved in helping our community build a maintainable tool that helps others build maintainable tools, that helps everyone develop better software. And like it or loathe it, it is used the world over. If you're a Minitest fan, you might want to go and watch Mario's Magic, because, you know, I'm an RSpec guy. So, in a way, this talk is about every one of you. If you've ever used RSpec, if you've ever used an open source project, this talk has a little bit to do with you. I wouldn't be here without the wider Ruby community, because I would have no job, because I would have nothing to do. And I kind of wanted to give back to the community that has given a lot to me. I kind of wanted to give back to open source, which is why I started contributing to projects like RSpec. And it was this time at RubyConf last year that I encountered a site called Code Triage. Have any of you seen Code Triage before? Oh, a couple of hands, that's good, that's good. Code Triage is a site that's dedicated to encouraging people to give back to open source. You sign up and you can say, follow some repositories and look at issues that are sort of meaningful to you. And it gives you an email prompting you to look at issues every day. That was how I started getting involved with RSpec. I'd always done little bits and pieces, but actually having that stream of sort of issues into my inbox encouraged me to go and write more code and more pull requests and more feedback, which eventually led to me and a few other people joining the RSpec core team. And we went from 1 to 5 people now working on RSpec to try and keep it up and running. Partly because we've been working on a new version, which I may get onto in a minute, but mostly because we wanted to give back to the community. So, what is this talk? It is about giving back to the community, but it's also about maintenance. Because any open source project that is of significant size, or any of your own commercial projects of a significant size, are eventually going to be running into maintenance issues. Some of you are probably thinking, maintenance? My code's perfect. I don't need to do maintenance. I only work on awesome code. This talk is not for me. Well, again, Mario's downstairs with magic tricks. But any project big enough or widespread enough is going to encounter differences in the way that the software is put together. Differences you probably won't have encountered on your machine. Differences that are probably not going to be encountered on your co-worker's machine, which if you're in any sort of trendy startup, are probably all identical MacBook Pros. Not everyone is going to be using those, folks. So you're going to run into environment issues, where you've got different Ruby tools. People use RVM, RBM, TrueRuby. Maybe they install Ruby from the package manager if they're a Linux user. Maybe they use the Rails installer if they're on Windows. But all of these things are adding up to differences in your environment. And you might find you run into interpreter bugs, because you're suddenly realizing that, well, there's 6 versions of MRI around in sort of rough usage. There's JRuby, there's Rubinius. So differing Rubies are going to mean you encounter different problems. And the biggest sort of maintenance headache you're going to encounter is unintended usage. I originally titled this slide user error, but I thought that was a bit unfair. Because actually it's not just users, it's actually people using things in the way you didn't perhaps intend. It can be your own fault for not documenting something and exactly how you think. You make an assumption how something works, and someone has a different assumption. And in the case of RSpec, some people seem to find they use the should syntax to do assertions outside of tests and expect that to work. I've not quite understood why that one happens, but it does, and it's something that we kind of need to account for. So if we go back to the environment, not the environment that Tony Abbott is trying to destroy, but going back to your development environment, at some point, your open source project is going to encounter someone who has a different idea of how things are set up. Like I said, you can have different forms of Ruby tools, you can have different operating systems, and your code is going to break. The worst thing you can say to these people is, works on my machine. Everyone's heard this phrase, but it's going to be a killer for contributing to an open source project. No user is going to help you if you just go, works on my machine, works on CI. You may be a little bit more technically polite and say, well, can't reproduce. But as a maintainer, it's your job to help people reproduce problems. It can be tough, but it's something you've got to work on. You've got to get better contributions from people by being kind, gentle, and teasing that information out of them. And I know I'm not necessarily always the best person to do that if anyone's ever interacted with me, but I do try to gently seek out the information. The worst question related to this is, does it work on Windows? It's kind of the stuff of nightmares when you're a Ruby developer and you're all on Macs. Someone asks that question and you go, I have no idea. There's 5 people developing on RSpec core now. None of us use Windows. We occasionally do get people filing issues in Windows, which proves that it is used by Windows users. But we struggle to help them because we have no environment in which to test it ourselves. Questions are at the end, Cliff. Come on. I discovered on Wednesday, in fact, when I was running a workshop, that someone did use Windows. I discovered the latest beta of RSpec doesn't output any colors properly, so half the text is invisible. That was rather embarrassing for me. But we do this on some hope on that front. I have heard a rumor that Travis CI may be supporting Windows in the near future, which kind of replaces the VMware argument, because obviously Travis is better than VMware. But even if it's not running on Windows, we're still going to have subtle differences between the way OS X and Linux handle things, especially when it comes to file systems and case-sensitive and in-case-sensitive file systems. Not every Ruby developer is going to be aware that if you spell a file name differently with uppercase on a case-insensitive file system, that file will require fine. You then stick it on a Linux machine with a case-sensitive file system. Yeah, so you've got to be aware of the differences in your environments. You've got to be aware that the differences in the environments you face. One of the other inconsistencies you're going to come across in your environments is encoding. Not everyone is going to come across problems with that. If you're just a web developer and you're output into a browser, a lot of things are taken care of for you. But encoding has always been a major pain if you're dealing with console output, because you've got to constantly think about the encoding of your files. And I don't mean that in case of, well, you just stick encoding UTF-8 at the top, right? But how that interacts with other people's code actually is going to be affecting you. This is especially true of a tool like RSpec, where we are actually loading things from a developer's file system, running them intermixed with our encoding systems, and actually outputting strings. There are plenty of people who use RSpec who don't speak English, and so they write their specs in Korean or Russian or French in a weird character set, which does happen. But we're also going to be aware that people, because it's a testing tool, are actually going to be doing stuff and testing changes in encoding. I've had people who have been stubbing out encoding.default internal and then expecting encoding to work correctly. It's kind of like, yeah, okay. And we have to be mindful of how that interacts with output encoding, because as RSpec is a console tool, it interacts with a console. The console may be a different encoding to our internals. That means that you're then going to get mixed output being displayed on, or in the worst case scenario, you'll discover that RSpec doesn't work because it tries to print to the console, the encoding mismatches, and it blows up. Encoding, how does it work? There's also a little issue with literal encoding. Now, most of you will be familiar with string literal. And the default string literal encoding, of course, is default string encoding.default internal, which for most systems is going to be UTF-8. But there are other things that are encoded. Regular expressions default to US ASCII. Yeah. Who knew? We didn't know until we tried to run a differ against this and tried to actually substitute parts of strings. that are UTF-8 or UTF-16LE, which isn't compatible with ASCII, and so blows up and produces strange errors for people. And you look at it and you go, well, obviously, they just used the wrong string encoding, until you start digging deep and go, no, something's going wrong here. Oh, no, literals. Oh, what? So yes, encoding. You need to be aware of it if you're working on an open source project, because you're not going to come across everyone who uses the same encoding as you. But let's move on from that to something a bit more interesting than encoding. Let's talk about Ruby issues. Now, before I sort of talk about the different interpreters, I just want to talk about some generic issues that you may trip up when you're working with other people's code. Who knows the difference between a block, a proc, a lambda, and a method? A couple of hands, good, good. The main thing that has tripped us up in the past is the differences between procs and lambdas. For one, lambdas verify arguments, so they behave like methods with fixed requirements. So if you're trying to use blocks to set up a stubbing tool, you suddenly get given a lambda instead of a block, because of course you can still cast a lambda into a block. Kaboom. Because suddenly you're trying to pass a number of arguments and you're expecting it to just handle it no matter how many there are, but it's a fixed number, you sort of have to go, oh, well, actually, I need to check the arity of this, I need to check that. And how do I even determine if it is a lambda? Because on 187, of course, you can't do .lambda question mark, because it doesn't exist. This was a problem for us, and we had to fix it. And it's not the only sort of issue like that. Now, who knows that monkey patching is evil? Good, I'm preaching to the converted. And this is kind of a funny thing for an RSpec guy to say, right? Because the should syntax that we sort of started with and spread everywhere is monkey patching. But we've been taking a lot of steps in the latest version of RSpec to remove all that monkey patching. That's what the expect syntax is all about. The main reason for its existence is to remove monkey patching from RSpec. And it's not just because we didn't like the aesthetics. It's because, well, active record, proxies objects, remove should. There are certain edge cases where they will just completely wipe out methods and won't restore them. And this breaks expectation frameworks. So we looked at this problem and go, well, anyone can do that. Just because one framework does it doesn't mean no one else is going to do it. So we decided to come up with the expectance. This is actually before I joined our RSpec core team. So I say we, it's the royal we, really. But it's still a good idea. And this is why we continue to recommend it over should. And although should is being deprecated in the latest version of RSpec, it's not going away anytime soon. You can all continue to use it. We just prefer if you use expect, because no monkey patching. We're going to be allowing you to turn off monkey patching for the entirety of the DSL. So you'll be able to do it all off the top level RSpec constant rather than doing it off the module constants. And you can therefore have a completely clean system. That's nice. It's in progress. So what sort of bugs are we going to interpret in our interpreters? So obviously we've got three main interpreters. We've got MRI, we have JRuby, and we have Rubinius. Now MRI has lots of different versions, as we all know, but I'm just going to focus on a couple of things that we've come across that not everyone's going to come across, but we certainly have. It's because, with MRI, it's the most widespread, potentially the most popular Ruby. That could be a contentious statement, I don't know. But it's certainly the one we've seen the most usage of. But it doesn't have a lot of strange, it's just sort of normal bugs, because they've mostly been found and fixed. As Charlie pointed out with his magic tricks talk, it does have some strange bugs. So occasionally you will encounter them and they will trip you up. We encountered one with public class method, which if you don't know what it does, it changes the visibility of a method to public. We were using that on a meta class to change the method to public so we could call it without having to use send everywhere. It turns out on 193 that leaks back and makes the method public everywhere. So tests will pass, run in production, and then blow up because the method's gone back to being private. Who knew? One of the more annoying bugs I've come across recently in MRI is that in 2.10 in RSpec, stack level too deep errors appear as seg faults. So we get people reporting seg faults in RSpec with detailed specs, and we look at their code and go, no, you've just got a recursion there. Quite why it's blowing up only within RSpec, we haven't quite determined. I think it's a memory issue. I think we're doing something strange, and it's just causing the stacks to, when it's going too deep, to use up too much memory and seg faulting before it raises the stack level too deep, but I haven't solved it. But yay, MRI. So let's talk a bit about JRuby. Now, if Hero's not here, is he? Good. JRuby, of course, is the enterprise-ready Ruby, so it plays well with your high-end performance needs, your not-so-legacy Java code, your legacy CEO, I kid. It's got some extremely awesome performance features, as I'm sure Hero filled us all in earlier on, but that's when it comes to running server-side code. When it comes to running tests, not so much. The median build time for RSpec is about 3 or 4 minutes for RSpec core, except on JRuby before our enhancements, it used to be about 50 minutes and timeout on Travis. And this is because JRuby has a terribly slow boot up time. You can sort of fix that with tools like Nailgun and stuff like that if you're running it in your development environment, but that doesn't help you on CI. And it suffers the same code reloading problems that like Rails code reloader suffers. And I personally don't really like those sort of tools because I feel like they're applying a band-aid to the actual problem. So we sort of had to look up working on reducing that boot up time. So we started tweaking it, and we ended up running into differences with the whole compiled versus interpreted thing. It's just not pleasant. And speaking of monkey patching, another good reason for getting rid of monkey patching, because although I've gone over on MRI, this is the ancestor tree for a 1.9 object. So the raw object class. If you can't see, it's an object kernel basic object. When you're monkey patching things like should, you want to go into the very basic, the very lowest level, so it's available everywhere. So basic object, or things break. This is what JRuby was doing. That says defined basic object returning nil. Yet you can use basic object, but it's not defined. And in fact, if you actually do it without the root constant lookup, it would return as a constant. And the same. We reported this, and they fixed it really quickly. It turns out the issue was they were using a different constant lookup mechanism in executed JRuby code versus compiled JRuby code. So they just switched it back to using the compiled one everywhere. But that's a difference between compiled and interpreted JRuby? Wait, what? That doesn't seem like something that's particularly consistent, because it isn't. So really, these sort of failures become prevalent when you start to deal with a just-in-time compiled system. We have an intermittent failure, and if there's any JRuby developers that know how to fix this, please come and help us, because we have no idea what's going on. We had to turn off client mode processing, which makes our build time slower again, because randomly 2 specs would fail on our build suite. Some doc strings would get concatenated to nothing. And we've tried to trace it, and we can't reproduce it on local machines, but it only occurs on Travis CI that we've been able to find out. JRuby. So another interpreter you're going to come across is Rubinius. So I'm hoping everyone's heard of Rubinius. But with Rubinius, it's Ruby with your JRuby. And, well, okay, yeah. But in all seriousness, they actually put a lot of work into making sure that the different Ruby interpreters behave similarly. They built RubySpec, thousands of specs making sure the behaviors are consistent across the different interpreters. And for the most part, it does behave just like MRI. Well, until they decided to extract the standard library into gems. Suddenly, the default solution to this now in Travis CI is just add gem ruby SL and just dump the entire thing back in. Why it's not done by default, I don't know. Because realistically, when you're trying to work out what part of the standard library or which gem name you now need to require to load it, it just gets all a bit confusing. And because Rubinius is actually a compiled language, like JRuby, we also run into things like this, which is a Travis CI dump of a runtime error called Rubinius toolset runtime compile error. So in the middle of running our test suite, it has tried to compile something and failed, and is therefore breaking the rest of the test suite. So again, if there's some active Rubinius developers that can help us with this one, please do, because it's beyond our level of knowing what's going on. But other than that, Rubinius is pretty cool. Now, so I've talked about some environment issues here. I've talked about some encoding and some interpreters, but I kind of want to talk about some more sort of specific to RSpec things that are going to be going wrong here. One of the things that we like to do is dogfooding. Now, I probably should have saved the YoDog meme for this, because, you know, YoDog were like RSpec and RSpec, and that's a Shiba Inu, if anyone's counting my memes here. I googled Shiba Inu eating and got this lovely slide. But someone on Twitter expressed it best, and I think they were trying to troll us, which is, what testing framework should I use to make sure RSpec is working? To which my response is, RSpec is itself tested with RSpec. What are you trying to do? Make a bad joke. Yeah, so we use dogfooding to make sure that RSpec does itself, but that presents its own challenges to us. And any testing framework that tries to test itself would suffer the same problems. And one of the things that is really bugging us is, well, who watches the watchman? Because we could totally make RSpec just say it was working and ignore the tests. That kind of we do have problems with false positives, especially with some of the matcher stuff. We actually had to work around our own matcher rescue code to make sure that matches were actually being tested correctly and they were failing when they were failing and passing when they were passing, because otherwise they would swallow their own exceptions, which gets a little bit interesting. I'm sure there's an Inception meme somewhere in here. But it's a bit like the liar's paradox. You know, this sentence is false. This failing test is passing. Yeah. We also have some things with problems with failures we cannot find, especially in RSpec core, which is the main runner. You'll do something, you'll change a line of code, and suddenly the entire test suite will break, and you've got thousands of lines of code and thousands of tests, and you're like, what just broke? Luckily, this doesn't tend to affect us that much because we do small things at a time, and then we get isolated failures. But if something changes in MRI or in JRuby, we can come across large stack traces full of just errors that are just throwing everywhere. It does get a little bit interesting. But one of the biggest challenges in maintaining a project RSpec is actually handling all of the different issues we get from the community. And the reason why I kind of wanted to give this talk today was kind of just go through some of the different challenges that we encounter as a team to try and make you realize that, okay, so there are things that go on there. Sometimes they're a bit scary, sometimes they're a bit strange. They can be fun, they can be not so solved. But without you guys using it and reporting stuff back to us, we're not going to find and fix them. So my aim in coming up here and talking to you all today is to encourage you to contribute back to open source, to open issues, to help us, to help you. And that's mostly what I had on sort of just talking about. So, however, I kind of promised some fun hacks. And this slide's for certain people in the audience, in that, well, we have some lovely customizations in RSpec. So we can use matches to define our own custom matches, to define our own expressive testing DSL. This is one of the things what sets us apart from test unit. And I'm sure you're all familiar with the different formatters that we can all use to write formatters. But have you considered that formatters actually do a lot more than just that? We have people who ask us, well, how can I gather metrics on this part of my test suite? Just because formatters are supposed to output to the console doesn't mean they have to. You can use formatters to gather information on a lot of parts of your test suite, or you can do some sort of slightly mischievous stuff, like, well, how about an evil formatter that deletes failing tests? That actually works. I coded that this afternoon. I figured, I've been saying, well, you can do this. Let's do it. Oh, yeah. Okay, that deleted my failing specs. Okay, so if you ever want to clean up a legacy code base. But more than that, you can actually use these for some for some good. This is something I actually use on one of my projects, which I call the integration fast failure. It's a custom formatter I wrote that will skip integration tests if my unit tests fail. Because it sits there and it waits and checks, is the test an integration test? Okay, well, if it isn't, I'm going to, and it basically quits if something has failed and it gets to an integration test. So it will run all my unit tests, and then it runs my integration test to go, oh, no, unit tests have failed, I'm going to fast fail here. Because it's slightly more edge case than using fast fail out of the box. I want to run all my unit tests, and then only skip the integration tests if a unit test has failed. Which is not the only thing that's going to be, it's not, you may wonder, well, how do you split these off? Well, it turns out, because RSpec is awesome and it has customizations out of it, you can register your own ordering scheme. So I actually split my test suite into unit and integration, randomized them. I mean, I had to do it myself, which is a little bit hacky, I guess. But then I run it through that formatter, and I can skip my integration test when my unit tests fail. It's the extensibility of RSpec that's kind of fun. Hopefully that's kind of interesting. And I'm not actually quite done, although this slide says thanks. But actually, I wanted to say thank you to a few other people, which is basically, without GitHub, without Travis CI, working open source projects would be a lot harder. I personally owe a lot to Code Triage. I suggest you all check it out if you haven't done. And I want to thank every single person whose avatar's on this wall, because these are all contributors to RSpec. I used it as a slide background earlier, but there's hundreds of people who have committed into RSpec to make it a project that we can all use. Now I'm going to say thanks. And thank you all for listening. Now you can ask questions, Clifford. Or heckle. I think, oh.
Do you have a gem of your fast failing formatter?
The integration fast failure, it's, well, one file, so no, but I could give it to you. Yeah, I can gist it. It's literally one file that I have in my spec support folder. Any other questions? No?
This is something I've been wondering lately as I'm running more and more new specs. Why do we still end all our spec files in _spec.rb when they're in the spec directory?
Because that's the way it's been done by convention, by ever. But you do know that there's an option that you can change to change that. You can actually specify the ending of the file names, and you can also specify where RSpec will look by default, and all of that can be stuck in your .rspec file, and RSpec will load it and parse it automatically.
So if you're Korean, you can do it with the Korean thing.
Yes, you could. I hope. Do you want me to write a test for that one? No more questions? Thank you very much.